Hello, and welcome to Chips Out Loud, a podcast series brought to you by Micron Technology. I'm your host, Jim Green. In each episode, we'll discuss emerging technologies in the memory and storage space. We'll also focus on the customer needs that shape evolving modern client devices, as well as next-generation data centers. I'm pleased to be joined today by Robert Beilby, Senior Director, Automotive System Architecture, and Marco Montagnana, Senior Manager of the FUSA and Cybersecurity Office here at Micron. Our topic today is going to be addressing the automotive market requirements and sharing the learnings from the journey of adapting standards-based technology to the real requirements, the tough requirements of the automotive industry. Welcome and thanks for joining us on Chips Out Loud.
Thank you, Jim. I really appreciate the opportunity to be here.
Yeah, thank you. Thank you for me.
Great. We're really looking forward to talking about the automotive landscape here. So let's start with the basics. You know, people love their cars and they also love their technology. Where are we generally on the path to the integration of computing with automobiles?
You know, at the end of the day, I think we're at a point where we have sufficient compute performance to really be able to address self-driving vehicles. And in the same way that we today rely on computers to, support spreadsheets and such, and it does a much better job with higher accuracy, et cetera, than humans. There's the same paradigm shift that's happening in the automotive landscape. The problem is a little bit more difficult than people had expected or anticipated. But, when you throw a computer at the problem, you've got eyes on 360 degrees visibility. They can see further than we can. They don't get fatigued, et cetera, et cetera. So it's inevitable and it's eventual that, computers are going to take over driving. It's just a matter of time. But with that, the topic of safety is a key one. And let me throw it to Marco and see if he wants to add any thoughts to this comment.
Well, just to add that also for my experience, the functional safety started with the classical automotive mechanical kind of application like powertrain, chassis, and so on, where even our kind of devices were not so important. I mean, the quantity of memory devices were not huge. Now, with the new era, with the ADAS, the autonomous drive kind of application, the quantity of memory is becoming more and more important, and the functional safety is important also for the memory. While in the past, people dealing with the functional safety were more focusing on microcontroller with embedded memories kind of application. And so memory devices standalone were less under the spot, right? FUSA-wise.
So it's a given that, each industry is kind of going to have its own kind of unique quirks or requirements, but I expect the automotive has some particularly challenging ones. And as you mentioned, it seems logical that safety would be a pretty particularly stringent hurdle for a lot of suppliers to have to deal with. Can you share some of the perspective of how the journey to integrate our tech with cars has evolved beyond what you shared earlier there, Marco?
Yes, for what we do here at Micron, we realize a bit, as I said, later with respect to the rest of the automotive world. And so we could take advantage of what already exists to some extent on the market, on the industry, right? So I was joining, by the way, 3 years ago, Micron, and joining the Functional Safety Office. That is the organization that Micron set up, put in place to drive the introduction of the ISO 26262 series of standards, that is the automotive functional safety standard, and took my experience, that I was coming from previous job, as I said, more in the powertrain, chassis kind of application, airbag and so on, and bringing into the new world of the memory standalone. And the challenge here was that it's not one-to-one matching. So what is applicable to those kind of applications like powertrain and chassis, as you said, it's a bit different. So we were learning a lot. We were also investing in a consultancy with an external third party. And the first effort was to understand the applicability in our context of the functional safety standard, tailor what the standard is saying to our kind of count of devices, right? So this was the first goal of Functional Safety Office. And then today we reached a good level where we are able generally to drive the rest of the community, the technical community, to face with the requirement of the functional safety standard. Just to give you an idea, the standard is 800 pages of requirement, right? They call a series of standard because they are up to 12 parts, right? So it was an important journey, and definitely the first effort, the first mission was to understand what is the applicability, and then launch a program at company level that was even sponsored directly by the CEO, and FUSA office was leading the program company-wide.
Excellent, excellent. I was aware of ISO from a standard, and I've heard of the FUSA terminology here. And well, you're relatively new to Micron. Micron has, a 30-year history in the automotive industry. So as you mentioned, it's kind of evolving where our technology and how our technology is packaged and implemented into platforms here. How big of a transition is it to move from, supplying technology to computers, right? Desktops and laptops and mobile. How different is it to translate and bring it to those requirements to an automotive industry?
The challenge is that, of course, automotive was already there, 30 years in automotive. In Micron, definitely it's the basis. So the mentality, automotive quality kind of mindset is the starting point, the background that you have to do. It's a must-have, right?
Mm-hmm.
IATF 16949 standard, a quality management system in place, and so on and so forth. But definitely functional safety is a cultural change, because you have to start that your device could not work. Typically, the engineers think about their device will work. They think about how to implement something that works. The change of mindset here is, please consider that your device will fail. Definitely will fail, even though you do all your best. So the approach is always to cope with that mindset. So we need to put in place some features that are able to detect those fail and notify the system. So in a way that at higher level, of course, not maybe at our level of memory, but in the system, something can be managed, can be triggered at vehicle level to bring the passengers, the driver, even the pedestrian that are around the vehicle in a safe state, right? Not to create any harm.
At the end of the day, the industry is moving towards more of an electrical implementation of solving problems versus mechanical. And with that, there's always a safety element with this. And from safety, there are two different distinct elements. We're looking at, have you designed a part to ensure that it's been designed to the best-in-class processes? And then there's the second piece, which is, okay, can you detect when a failure has occurred? And then by delivering that information, the OEM, the tier one, the designer of the platform can decide what's the right response to the fact that a failure has been detected.
Great. So it really touches everything from the initial design all the way through the delivery, through the quality, manufacturing, and all that other capabilities there. But the other part is that big change in mindset to plan for failure versus, plan for success, which is kind of a really interesting mindset change. As an example for our audience, how is the way the auto market looks at what we consider something that's a pretty standard thing like DRAM changed?
Interestingly, when the ISO standards were established around safety, they've pretty much taken a set of standards and then adopted them for the automotive industry. But there's been a misunderstanding in terms of how much complexity there is associated with DRAM. We have taken a more aggressive posture in terms of the importance and the underlying technology that's associated with DRAM. And as a result, we've put a much more aggressive footprint in terms of designing our product to ensure that it's designed to truly the best in class based upon a class 3 versus class 2 product. But in general, DRAM plays an incredibly important role in automotive from an embedded platform standpoint. There is no platform that has more lines of code than automotive. In fact, it's going to move from 100 million lines of code for the most advanced platform to 300 million lines of code.
Wow.
Yeah, it's staggering. And, there is absolutely zero tolerance in this environment for failure, in the same way that if this were your bank account and there were some ability to adjust a decimal point because of an error, you would either be excited or really disappointed. Same holds true for automotive.
Also, you talked about the code, the line of code, but now also the huge amount of data and the criticality of the integrity of those data is becoming important, right? Because now with the autonomous drive and the image processing, LiDAR kind of data processing to rebuild the reality around the vehicle is something quite critical, right? So recognition with artificial intelligence of objects, distinguish objects between different types and so on, it becomes very, very important. So the amount of data that we have to store and process, it's booming, right? And errors there becomes important. Even few errors start to become critical. And this was not the case in the past, right? As we said before. Now, with the new technology, with the evolution of the vehicle and the technology around this, it's very important to take into account functional safety also for DRAM. But also not only DRAM, right? Then we can extend the same to other devices like non-volatile memories and so on, maybe with different level of criticalities, but the same can be applied there.
Excellent. Wow, it's interesting, 30 plus years of automotive history, and the journey's really actually kind of just getting started and really has a bright future. Robert, Marco, thank you so much for joining. I look forward to hearing more about this journey because it looks really exciting ahead. So thanks for joining us today.
Thank you.
Jim, I appreciate the opportunity. And what I continue to tell people is that the amount of innovation and disruption that's happening today is far more significant than actually the initial introduction of the vehicle 130 years ago. It's quite profound. And watch this space. Transportation is going to be redefined, right? Thank you.
Awesome. Great. Thanks again, guys. So yeah, folks, thanks for listening. You'll be able to check out some of these new technologies and hear some of these stories and watch this evolution by following at www.micron.com/solutions/automotive. And certainly you can learn more about Micron at www.micron.com/careers and engage with Micron Technology on LinkedIn and in the Twitter sphere. We look forward to speaking to you again on the next episode of Chips Out Loud. Thank you to our audience for joining. Please listen in again on the next episode of Chips Out Loud.